Resistance. Analogy between juice flow and current flow. What is resistance? Resistance is the measure of how difficult it is for charges to flow through an object. Now, in order to understand the meaning of the resistance, we have to do the following activity in order to determine what are the factors that determine the resistance of an object and to better understand the concept. We have different shapes of straws. Straws are available for drinking a juice. There are straight and curly straws as shown in the adjacent figure. So we have the curly long straw, the red one, and a short white straw. Upon using which one of these straws does the juice need more time to reach the sipper's mouth? For sure, it's the longest straw. The longest straw that the juice needs more time to pass through the longest straw and reach the mouth of the sipper. Now, that was a question considering the length factor. What about these straws of different diameters that are available for drinking? The adjacent figure shows two straws of the same length now, but different diameters. One is 6 mm wide and the other is 10 mm wide, respectively. So upon using which one among these straws does less amount of juice reaches the sipper's mouth? It's the narrower one of diameter 6 mm. So we can see that if the straw was longer and narrower, the juice will take more time and less amount is going to reach the sipper's mouth. So deduce how does the straw's length and diameter affect the quantity of juice flowing through it during a given period of time. As the diameter of the straw decreases, its length increases. The rate of flow of the juice decreases. So as the diameter of the straw decreases and its length increases, so we said longer straw needs more time, narrower straw less amount, so the rate of flow of the juice decreases. Knowing here that the straw represents the conducting wire in an electric circuit, express the above conclusion in terms of electric resistance. So how can we relate the above conclusion to the electric resistance? Simply here the straws represent the conducting wires. So as the diameter of conducting wires now, instead of saying straw, as the diameter of a conducting wire decreases and its length increases, its resistance increases. Let's recall that insulators do not allow the flow of current through them since the electrons of their atoms are tightly bound to the atoms. So while conductors allow flow of current through them, since the electrons of their atoms are loosely bound to the atoms, you can refer back to previous slides and check the diagram that shows how conductors have free electrons around their atoms that are ready to flow through the material when some voltage is applied across the material. So they easily respond to external voltage or to external energy and allow the flow of current. However, insulators do not really respond easily to applied voltages or to external electric energy. That's why, what do you think? Indicate whether conductors or insulators have lower resistance and explain. So those that allow more flow of current have less resistance for sure. So they do not resist, they respond directly and allow the flow of the current. So now conductors allow charges to flow more easily, so they have lower resistance. So based on all the previously answered questions in the section of resistance, list the 4 factors that determine the resistance of an object. The length affects the resistance. More length, more resistance. The diameter being narrower means more resistance. And the material, we mean whether it's a conductor or insulator, or even if we want to compare more than one conductor, each one has its own resistance. So some material are more conductive than others, so they are less resistive than others, and so on. And the temperature is the 4th factor. Now again, summing the same ideas here, which wire has greater resistance in each case? whenever we want to conclude or to compare two things, we have to take control of some factors and vary only one factor in order to study its effect. So here we have two copper wires A and B so the same material here, same length, but of course at the same temperature. But here the diameter is different. So we have diameter R and here diameter double R. So which one has a greater resistance, the one with diameter R or diameter to R, the narrower one or the wider one? For sure it's the narrower one. So this one has greater resistance. What about comparing C and D that have the same length? Sorry, that have the same cross-section area and both have the same width, and both are made of copper, and both are put at the same temperature, but one is of length L and the other is of length 2L double L. So which one has more resistance? The longer one. It needs more time for the electric current to pass through it. So these are the ones that have greater resistance. Now, in order to confirm that temperature does affect the resistance of a material, we did an experiment for sure for different material like platinum, nickel iron, and copper, and we increased the temperature for each one of them gradually. And while increasing the temperature, we connected an ohmmeter across them in order to measure the resistance of the material. Then we collected the information and plotted it in a graph of resistance versus temperature. We noticed that for all the material, as the temperature increases, the resistance increases. So yes, the temperature does affect the resistance. So as temperature increases, resistance increases. Now here I'm showing a table in order to confirm that though مثلا both are conductors, or those مثلا we have two objects that are both insulators, but this doesn't mean that being a conductor or being an insulator means all conductors have the same resistance and all insulators have the same resistance. This is not true. So if we want to compare copper and aluminum, this is copper and this is aluminum here, and this table shows resistivity of materials, which is related to resistance. So we can see that copper has 1.68 times 10 power minus 8 ohm dot meter, while aluminum is 2.82 times 10 power minus 8. So we can see that aluminum is more resistive than copper and thus has a greater resistance. So here, summing up or showing you the formula that relates the length, the surface area, and the resistivity related to the material, we can calculate the resistance of a certain wire. So resistivity is more related to a material. So like all things made up of pure copper have the same resistivity, but do not have the same resistance because the resistance is affected by other factors like the length and the surface area. So this is the difference between resistivity and resistance. Like each wire has its own resistance. Each copper wire, for example, has its own resistance, but all copper wires have the same resistivity. It's just like when you say, like it's the identity. The resistivity is the identity of the material. It doesn't change, but what changes is the resistance. It's affected by the length and the surface area. Now, then resistance is the measure of how difficult it is for charges to flow through an object. And here we have a diagram showing, or an illustration showing that a source of voltage in the circuit, in an electric circuit, tends to push the current through the circuit. However, the presence of resistors or resistant materials make it difficult for the current to pass it through. And one more note here, that the collision between the charges and the atoms of the resistant material produce heat. So when the charges pass through the material, through resistant material, finally this material is made up of atoms too and has electrons. So the collision between these charges produce heat. That's why high resistant materials So that's why upon applying a voltage across high resistant materials and allowing the flow of an electric current, these high resistant materials produce heat. So resistance is measured by a multimeter used as an ohm meter, and the unit of measurement is ohms, as you can see. Now, real life problems, I'm going to talk about it in the next video.